This episode is sponsored by Datadog, a cloud monitoring platform built by engineers for engineers, enabling full-stack observability for modern applications. Datadog integrates seamlessly to gather metrics and events from more than 400 technologies, including cloud providers, databases, and web servers. Easily identify slow-running queries, error rates, bottlenecks, and more fast with built-in dashboards, algorithmic alerts, and end-to-end request tracing and log management. Datadog helps engineering teams troubleshoot and collaborate together in one place to enhance performance and prevent downtime. Start a free trial today, and Datadog will send you a free t-shirt. Visit datadoghq.com/HanselMinutes. That's datadoghq.com/HanselMinutes to get started. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Jeremy Sinclair. He's a Windows Insider's MVP, an internet person. How are you, Jeremy?
I'm doing great. How are you doing?
I'm getting there, as much as anyone can be right now. I have been watching you on Twitter for a very long time. We've hung out a number of times as well. And you really like your Surface Pro X. Now, I'm surfaced. You know I'm surfaced all up left and right. I've got all kinds of surfaces. But what is so special about the Surface Pro X?
Well, this Surface Pro X, it is the first Surface device that Microsoft offered that runs completely on ARM64. So we have a Windows 10 ARM64 device that is Surface branded.
So I remember when everything was x86, which is Intel X0, x86. There was 386s and 486s. And then there was a time when we were going from 32-bit to 64-bit. And I don't think that a lot of users noticed that time. A lot of devs had recompiled things. But when I'm on my Intel machine and I'm running a 32-bit process or a 64-bit process, I don't really think about stuff too much. I don't think that anyone anymore thinks about it. And now 64-bit on Intel is pretty much a standard deal. But ARM, that's a whole other universe, right? This isn't an Intel chip. This is a totally different architecture. Is that correct?
Yes, absolutely. This the ARM system on chip, SoC, it's a RISC processor. So you have that reduced instruction, just kind of like the PowerPC, if you think about that. The Intels, the x86, those are all complex instructions. The biggest difference I can see between the ARM and the Intel processors is that you have the low power efficiency that the ARM provides.
So I understand that Intel has their expertise, and this is a bit of a generalization, and the kind of things we're going to talk about here are kind of generalizations, but Intel's expertise is to design, the basically high performance processors. Their goal is perf, right? Desktop and server. But ARM has only ever focused on power efficient. That's their whole thing, is let's be efficient with power. It's almost like ARM fundamentally sees computing differently from Intel.
Correct. And what I believe by that is by focusing on that low power standpoint, there's going to be a lot more optimization. You're going to get a lot more done without pulling a lot of energy from the processors. And if a lot of the ARM system chips don't even have fans in them because they're meant to be that low power, but get a lot of that performance out of it.
Interesting. Okay, so you're saying that while we are trying to figure out ways to make fans quieter and Surface, I have a Surface Pro 3, which is quite a bit older, it's several years old, but it's got a tiny little fan, and there's all kinds of discussion about the vents and how the fans work. This Surface Pro X doesn't even have a fan. There's just no concept because it's just not how it works. It doesn't need a fan.
Correct. And another wonderful thing about this, if you think about ARM64, the phones that you have, they're running ARM64. If you think about the battery life you're getting out of that, getting out of your phones, your iPhone, your Android phones, you're going to have that same similar performance on here.
Okay. So someone once called the ARM. ARM basically is the architect of the smartphone era. I think that was a quote in The Verge. Basically, they kind of thought about and invented the idea of mobile system on a chip. Like put everything on a chip, shove it into a tiny device that requires all day battery life and no fan. So these are phone chips, but phones then are becoming computers in our pockets.
Yeah, and if you think about something that I've seen happen quite a few times, phones being used for full movie and audio production. Like a lot of the
Yeah.
DJs and music producers, uh, most of the time they're carrying around mobile sized devices. They're not carrying around full laptops, full desktops
Hmm.
anywhere. They have their mobile devices with them because a lot of the audio code and people have seen how efficient everything is. So it's like, why carry around this beefy machine when we have all of our code optimized just for this?
Yeah, we've seen people do like entire albums on, GarageBand or make small, or even I think there've been a number of movies in the theaters that have been done entirely on like iMovie. So certainly the idea that a phone can't do something major, like those days are over. But I remember that there was a couple of devices where Microsoft tried to make it so you could plug in a phone to a giant monitor and like run the whole thing. What was that? I don't remember what that was called. But during the Windows Phone 10 era, there was an idea that you would carry the phone would become your computer basically.
Yeah, that. Oh, this is bringing me back. The Windows 10 Mobile Continuum.
Hmm.
That was the device. I mean, that was the function, and I actually feel like that was maybe a preview of what we could expect with the Windows on ARM.
So Windows on ARM means not Windows Phone 10. It means literally the Windows 10 that I'm already using, Home or Pro or whatever, on an ARM device, but not necessarily a phone-sized device. The Surface Pro X is tiny though. It's the size. It's almost basically an iPad. It's the size and thinness and weight of an iPad, but it's a full PC.
Yep, absolutely. It's the full OS. So many of the functionalities that you'd be able to have on your whatever your uh, Surface Pro or Surface 6, 7, all of those. You'll be able to do this on the Windows on ARM. So I can actually run WSL on here, for instance.
The Windows subsystem for Linux. So you could,
Yep.
which uses a virtual, uses Hyper-V and a number of virtualization technologies. So you can kind of go nuts. So you use yours as a development machine?
I actually do. That I think from talking to many people, that's been one of the first things they do if they get an ARM device. First thing they do is, oh, let's see if Visual Studio runs on here. So you can guess that was the first thing that I did was download and run Visual Studio on there.
And did it work though? Because Visual Studio isn't ARM compiled.
It actually did work because of some awesome things that the Microsoft teams have done to make that possible. There is a x86 emulation layer that runs on the ARM64. So you'll be able to run x86 binaries. Only x86 though, not
Okay.
x64.
Okay, interesting here. So hang on. So this is an ARM 64 chip, not an ARM 32, and you can run, I assume, ARM 32 things as a kind of an emulation as well. So just like I was mentioning before, my 64-bit Intel machine, my desktop that I'm talking to you on right now, so it can certainly run 32-bit apps, and that works fine. I don't really think about it. Um, and this ARM64 version of Windows 10 uses a layer. It's not a virtual machine though. It's an emulation layer. So it's literally absorbing those instructions for x86, converting them in real time onto ARM. It's lying to the app and telling it that this is an x86, and it works.
Yep, absolutely. That's why you would typically see as an alternative to the lack of ARM64 binaries. If there's an x86 binary, they say, hey, just use this. Which the performance of that x86 emulation layer it's okay.
Mm-hmm.
It
You
is.
didn't sound enthusiastic when you said okay.
Yeah, it's I'll say it's better, and I'm going to give a comparison to my first ARM64 device. It was my Asus Nova Go that I got at Build in 2018. The x86 emulation on that was pretty abysmal because it had a Snapdragon 835, which was the same processor that's in my Razer phone,
Mm-hmm.
which interestingly enough. Uh, it's running Visual Studio on that. Just be prepared to suffer because there's a lot of processes going on. There's a lot of sub processes.
Ah, that's interesting.
The more x86 processes you're running at the same time, and
Mm-hmm.
if there's anything that's dependent on that, just goodbye to your performance.
Okay. So let me think about this for a second. So this is a great device. It's a great idea. The idea of an ARM64 device means a fanless, low power, architected for low power at the very beginning device, a device that gives you all day or darn near all day battery life. But if I start using that device to exclusively run 32-bit applications on an emulator, especially complicated ones that fan out, like you said, the Visual Studio as an example is kind of like the torture device, the torture example, because it's like dozens of processes that fork out because it's not one app, it's dozens of little apps that all talk together. Then at that point, I'm not using the device kind of in the way it was intended. It's great that it works that way, but I'm going to probably not get awesome battery life, and I'm not going to get awesome perf, and it's not going to make the device really shine.
Correct. Yeah, and it's really like you said, it's the complexity of the x86 app that determines your level of performance.
Mm-hmm.
Like say for existence, Microsoft Teams actually runs pretty well. There's been a lot of optimization, and I can really kind of attribute it to the improvements that were done on the I guess the video performance and a lot of that. Plus, we've had firmware updates for the Pro X
Mm.
that have made the experience amazing. It's
So they're
before.
really actively trying to make this thing awesome. Like it's getting
Oh yeah.
updated regularly.
Oh yeah, which is really nice.
Mm-hmm.
I mean, there's obviously there are bugs, which they're random, but the biggest thing I try to remind everyone to do is if you encounter any random bug, add it to the the feedback hub.
The Feedback Hub app, yeah.
Yep, I can say that every single time I run into something that's out of the ordinary, I throw it in there and I make sure that I do the biggest amount of detail in there just so the engineers can you know, understand what I was doing at that time because I want this stuff fixed too. I want this to run completely flawless.
Yeah, definitely people are paying a lot of attention to that kind of stuff. And this has only been 6 months since the device came out. So
Right.
certainly now, but at the same time though, like I always thought that they should have called it like not Windows 10 ARM or Windows 10 on ARM. I would have called it, and this is just me making this up, but I would have called it Windows 10 All Day Office, because the thing that I like about the Surface Pro X is that it'll just basically run forever if you don't throw a bunch of emulation stuff at it. Right. Like if you think it's the perfect all day machine for dev and all you're going to do is emulate an x86, it's probably not for you. It sounds like if you're running native ARM, though, stuff, it'll just run forever, which is pretty cool.
Oh, yes. And for instance, the first thing I did was download the new Microsoft Edge that's Chromium based and put it right on this laptop. Well, I call it a laptop, but my ARM 64 Pro X device.
Mm-hmm.
Because, and everyone, there's been jokes for years about anything Chrome related, how it just loves to eat your memory. So imagine running that a base, uh, full Chromium based browser on x86. It's You'll see the complete difference between the x86 version and the ARM 64 version. There's many times where I could actually, and this might be just my own opinion, but I've seen x86 run horrible. Why? While the ARM 64 version of these browsers run better than my x64 based Dell.
Really?
Yeah, I usually have a good 20, 30 tabs open at any given time,
Mm-hmm.
and I have really no issue.
What does better mean to you? Like, I think that one of the things that's hard when trying to explain to people the difference between this ARM machine and a comparative Intel machine is the sense of it runs better. I mean, there's no fan. It is efficient and it is crisp, and you click and things happen instantly. So you're saying better how? Can you be more kind of quantitative about that?
And yeah, it's really kind of better depending on what you're doing.
Mm-hmm.
I put browsing in there as an example because I've seen most people when they're on their devices, whether it be a laptop, desktop, tablet, you're going to have your browser. That experience is significantly better than what I've seen on my work machine that has 32 gigs of RAM and 8 core Intel processor. It feels like it's those tiny wins,
Mm.
but at the same time, you still have to. You're still gonna have to think about the level of complexity because on these devices, you're not gonna be running a full blown super video game like I don't know. I'll bring up an old example like a Crisis. You're
Well, or
not going to
Gears of
run
War,
that.
right? I mean,
Yeah,
unless Gears
Gears
of
of
War
War.
was a native ARM app, though this isn't what this is for, right? I think when I first got a Pro X, I thought this was supposed to be the perfect computer. Like, this solves everything in the sense of this is going to be as high powered as my desktop, and it was going to be everything that my Intel was and more. And I think I got my head wrong about that because, like we said at the beginning, Intel makes high performance server desktop machines, but ARM makes power efficient processors from the beginning. And this is a really grown up phone processor that's a system on a chip. And my expectation wasn't reasonable and it wasn't correct because that's not what this is for.
Correct, and that's why there's been that example from the beginning to say, hey, this can do a lot of stuff. It's really great for productivity,
Mm.
but don't expect to use it as a gaming machine.
Which
Just
makes sense.
right. And I think that as the processors gain more complexity, because just the change between a Snapdragon 835 to this Microsoft SQ1 based off of the Qualcomm Snapdragon 8CX,
Mm-hmm.
the difference between the performance is insane. Like, and I think the more complex, the more that we see evolution of the ARM based processors, I feel like it's going to get to that point of being a true contender.
Hmm.
Because I've done the Geekbench was it Geekbench 4 or 5
Hmm.
on this Pro X, and it was comparative to an i5
You
processor.
know, that's interesting. That's like the benchmarks that they do on iPads and stuff when they're trying to show, like an iPad, I don't think is comparable to a PC. But if you take a benchmark that is a browser based benchmark and you say, if you spend, most of your time, 60, 70, 80% of your time in a browser, it is comparable and you can get a lot of really significant work done.
Yes, and I I think that's where you get a lot of those wins.
Hmm.
But I do believe that I think OS wise, as Windows gets more ARM 64 binaries out there, and as the OS itself continues to get optimized, this may not be a problem. Because if you think about it, you've seen like ARM 64 has been out since about 2010, not implemented,
Hmm.
but you know the ARM V8 has that spec has been there, and Linux has been on it since then. So like 2013, I think you started to see your first Linux based build of an ARM 64
Hmm.
target, and there's a lot of stuff running on Linux ARM 64 out there.
Yeah, we're seeing a movement of ARM, not just from the phone, but up into the cloud as well. The idea of this power efficient processor means that if I could do, a .NET web app and run it on ARM in the cloud and not even think about the fact that it's written on ARM, if it just works, then, the entire data center could be more power efficient and that could cause, potentially save, I don't know, millions of dollars because we're not using as much power to keep or cooling to run the cloud. So I think there's a really interesting thing to be said there as well. Now we're going to have processor wars again.
Yeah, and I think that's really great because especially as a .NET developer, I know the latest .NET 5 previews. There's the SDK targets ARM 64 on Windows, so I've been actually able to compile full on .NET Core apps, and they work. So console, ASP.NET Core, and for right now, WinForms. There is WinForms support in the latest .NET 5 uh, previews, at least from the latest bleeding edge version,
Mm-hmm.
which I think would be towards like preview 5 ish or even preview 4. I have to look again, but yeah, there's I've been creating WinForms apps
Mm-hmm.
and they've worked flawlessly. That's what's blowing my mind.
When you need to focus on building, do you want to get bogged down by your database? MongoDB is an intuitive, flexible document database that lets you get to building. MongoDB's document model is a natural way to represent data so you can focus on what matters. MongoDB Atlas is the best way to use MongoDB. It's a global cloud database service that gives you all of the developer productivity of MongoDB, plus the added simplicity of a fully managed database service. You can get started free with MongoDB Atlas at mongodb.com/atlas.
I was looking at your blog here, and you've got a blog post from February where you compiled the ASP.NET Core runtime for ARM, Windows ARM 64. There's already a Linux ARM and Linux ARM 64. So folks have been able to use ASP.NET and .NET on Raspberry Pis with success for a long time. I've got a number of Raspberry Pis, and I've been talking about that for years. But it doesn't look like you had to do a whole lot to recompile that. You basically made your own runtime identifier and just compiled it all with existing tools. Did that take a lot of effort to get .NET Core running on ARM 64 on Windows?
Yeah, it took a while because at that time, which I guess this is my fault for not updating the blog, that process is actually the amount of complexity of that process is essentially gone.
Mm.
They've the
Did that
.NET
for you now?
yeah the .NET team has done so much.
Mm.
But it was a lot of trial and error on my part because it's the
Mm-hmm.
first time I even brought down the entire .NET Core source. Because so for me, trying to make this run and build natively,
Mm-hmm.
I gained some experience with looking through the .NET source and gaining an understanding for how that process works.
Mm-hmm. Were you impressed? Was that like, were you like surprised at all? Because I know that Microsoft always talks about being able to compile all of .NET yourself, and you're just like, yeah, I'm just going to compile .NET for a totally different processor, and I actually could do it. Like it was a real thing.
Oh, I was extremely impressed. I Because as soon as I did it, I had to run .NET, and I made a simple ASP.NET Core app that just shows the runtime of the binary of whatever the host process, and
Mm-hmm.
just to see that ARM 64 there, like it just blew my mind. It made me
Mm.
so happy because you know, currently when you're downloading anything .NET Core related and using it, it wants everything wants to use x86
Mm-hmm.
because there's no publicly available, I guess, general release of the SDK for ARM 64. So trying to compile something in the x86 version of .NET versus the ARM 64, it is day and night.
Let me ask you this. Here's a bit of a loaded question. So I'm thinking about two different people. There's you who have the technical ability and patience to compile all of .NET for the processor that you love, and then there's maybe my non-technical spouse. So if my non-technical spouse gets a Surface Pro X, they're going to be able to install Office, install every app that they want to run. I mean, other than like obscure low-level drivers and weird VPN apps that might do something custom, they're not going to have any trouble running whatever. Like non-technical spouse can run whatever makes them happy on one of these devices, right? But if you're a dev, how much hunting around do you usually do for an ARM native build of something? When you're like, yeah, I want to run Edge. You said you got the ARM build. How important is that, and how much time do you spend doing that?
I always go out searching on the individual application. I go searching to see if they do have an ARM 64 build, if it's open source. First thing I try to do is see, okay, how can I make this cross compile?
Mm-hmm.
I get down to that level because it's more of a a learning thing for me, but also a way that I can contribute back. But there's only been really you know a few things I've wanted to see. Well, and I've wanted to natively compile to ARM 64 that weren't there,
Mm.
and well, VS Code being one of them. And there was a pull request by was it Rich Townsend that enabled all of the prerequisites in order to make a build for ARM 64, and that's what essentially became the insiders with a few tweaks to it. But
Mm-hmm.
that was the one thing I did. I even compiled it. Actually, the first thing I did with VS Code was I opened up um, Windows File System for Linux, got it compiled there, used VC Xserve to do like a X11 client or whatever to see the actual GUI. So I
Mm-hmm.
saw that Linux app running on Windows System for Linux,
Mm-hmm.
the GUI on my screen, and I was debbing in that.
Mm.
So it's like that. That's where a lot of the fun things with having Windows Subsystem for Linux works out. Because if there's something that I feel like, okay, this, I don't need anything Windows specific
Mm.
from this. I can just load it up and run within that little environment and be done with it. Like So there was a little trade off. There is like the alternatives, because there is like for instance, I think the Windows on ARM only supports OpenGL 1.1, and that's there's many things that if it does support OpenGL, it's not going to be targeting 1.1.
Is that an older thing?
Yeah, it's an older thing.
Okay.
But the cool thing about this is I ran like Quake 3. There was like open source Quake 3 that could not get compiled properly yet. There was a lot of, weird things that I ran into. I opened up Windows Subsystem for Linux, downloaded the package, and ran it. And I'm playing Quake 3 on my Pro X through.
And it worked just fine out of the box.
Yep, absolutely.
So it sounds like, even though, like I said, we're just 6 months from the release of this, and it's the beginning of Windows on ARM, for the average non-technical Joe or Jane, it'll just work. Mm-hmm. For when Edge has ARM builds, the new Chromium-based Edge has ARM builds available that you can find, but at some point that'll just work as well. Like everyone will just get the latest version, so non-technical spouse will have a faster browser, and they don't have to do anything. I know that Visual Studio Code Insiders has ARM builds, so Visual Studio Code itself will compile directly on ARM. It seems like if more people start using, getting ARM stuff, it'll just happen. Basically, the machine will just get faster and the battery life will get longer because x86 compiled emulated apps will slowly, over the next several months to a year, be replaced with ARM native builds, and everybody wins.
Yeah, I believe that. And that's one of my goals, to bring more awareness. Because in Visual Studio, it was like back in 2018, we gained the ability to easily target ARM64. Mm-hmm. So for right now, if you have a C++ project, you can easily add a target for ARM64. And I'd say 99% of your builds will just work, because there's been that, you think about CMake and even Rust. There's all of those different components have ARM64 native compatibility. Mm-hmm. So a lot of these big apps can just be easily ported without trouble.
That's cool. It's amazing to me, even that on ARM64, that there's a VHDX that you can run Hyper-V on these devices. Like the idea that you can run Hyper-V and Windows 10 Enterprise on a Surface Pro X running, this ARM Snapdragon style processor. The idea that what's effectively a giant phone with all day battery life has the ability to do these kinds of things. It sounds like you are a big fan of this device.
I'm a huge fan, and more than anything, it's the first device I pick up, and I'm on it the entire day. Mm-hmm. So just about everything I'm doing, even this recording, is done from my Pro X.
Oh, you're on it now?
Oh, yeah.
Oh, wow. Okay. And then you have like a USB mic plugged in? Like you're just using it. It's a PC. It's plugged into you give it on the dock and it's running 2 monitors?
Yep. I've done that. It's amazing. I thought that I was going to have so much issues, but I've had none with just replacing the device that's hooked up to my monitors. I have the first generation Surface dock, which still works flawlessly. Mm-hmm. I even have a USB-C to USB-A converter, and that's what I'm using right now for the mic. But even then, I have a what is it? An Arturia MIDI keyboard. Mm-hmm. I plugged it into this and used FL Studio Mobile, and I'm playing this keyboard without any delay. Wow. I can actually make music on this Pro X.
Sounds like you're living the dream, man.
Oh yeah, and that's me. I try to find everything that I can do just to get the best out of the device.
All right. Well, thanks so much for chatting with me today. I hope that folks check out what's happening in the ARM space and that this maybe has them give a second look at the Surface Pro X and what's happening with ARM on Windows. Thank you so much, Jeremy Sinclair.
Thank you so much, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.